Then question number 31. Two masses, capital M and simple M, placed on frictionless horizontal surface are connected together as shown in the figure using a spring whose mass is negligible. Two masses are first placed together so that spring is compressed and released. If the initial acceleration of mass simple M is A, what would be the magnitude of acceleration of capital M at that moment? We know that the force exerted by two masses are equal and opposite because of the two masses are connected with same spring. Therefore, initial force for releasing point is constant for both masses. Force constant, therefore we can write force on simple M should be equal and opposite to force on capital M. We know that F is product of MA, mass into acceleration of simple mass, the simple M mass should be equal to mass into acceleration of capital M mass. I will consider acceleration of capital M mass is A dash. Then we can find A dash, simple MA divided by capital M. Then answer should be 4 for the question number 31. Then 32. A cricket ball of mass 0.15 kilograms travelled with speed 20 meters per second just before batted by a batsman. When he batted, the variation of force exerted by the bat on the ball with time is shown in the graph. If the half bounces back in the opposite direction, speed of cricket ball just after batting is. If the half bounces back, we can get change of momentum equals to area of graph. Area of graph half into base 0.001 into perpendicular height 13,500. It should be equal to change of momentum. We have to consider the direction of the ball. Before the collision, ball is moving in this direction. I will consider the initial velocity v. It is 20 meters per second given in the question. After the collision, we have to find the velocity, same mass. When considering difference, change of mass, change of momentum, final momentum is mv. It is in this direction. We have to subtract m into 20. It is in opposite direction. We have to use minus mark, opposite direction. Then we can substitute m value and find the value of v. I will cancel out 2. 2 divided by 2, 1. 13 divided by 2, 6. 15 divided by 2, 7. 10 divided by 2, 5, 0. When multiplying by 0.001, we have to separate 3 decimal places. 6.75. Mass of the ball is 0.15 kilograms into V minus into minus plus 0.15 into 20. Then I will multiply this term and get to the left hand side. 6.75 minus 0, 2 into 15, 30. We have to separate 2 decimal places. 3. 0.15 V. Then we can subtract 3.75 divided by 0.15. When dividing, there are 2 decimal places in numerator and there are 2 decimal places in denominator. We can divide without using decimal places because of there are same number of decimal places in both sides. 37 divided by 15, 2, 7 remaining, 75 divided by 15, 5, 25 meters per second. Then answer should be 2 for the question number 32. Then 33, an artillery gun is positioned horizontal ground and an artillery shell is fired from it so that shell would land at a target which is located at a distance 2000 meters from the position of gun. Accidentally, the shell is exploded into two pieces A and B at a certain point of trajectory. The mass of A is twice that of mass of B, and both pieces are landing at the same moment after traveling the same vertical plane. If A lands at a distance 1800 meters in the direction of target from the gun, distance to the landing point of B from the gun is. They have given that the time taken to land after the explosion is same for both parts. Then it should be explode in the maximum point of the path. Therefore, we can consider motion of shell. It is like this. But due to the collision, due to the explosion, both pieces are moving in same plane, but there are two different horizontal displacements. But the explosion is in the highest point. Therefore, there is no resultant unbalanced force on the system in considering two parts of the shell. Therefore, center of gravity of the system is not changing. Now they have given part A lands at a distance 1800 meters. 1800 meters. We have to find the landing distance for part B. I will consider it as X. Target is this one. Distance from gun to target is 2000. Therefore, this part is 200 meters. Due to the explosion in this point, it means highest point, there is no external unbalanced force on the object, on the system. Therefore, center of gravity is not changing. Then we can use center of gravity of system should be this point. It means torque on part A around this point should be equal to torque on part B around same point. Then I will consider they have given that mass of A is twice mass of B. It means this mass 2m, this mass m. We can consider torque around point O. Torque around point O. 2m into distance 200 should be equals to m into this distance y. We can cancel out m, then y is 400 meters. Now we can get distance from gun to the piece B, 1800 plus 200 plus 400. 2400 meters. The next value is 2400 meters. Answer should be 3 for the question number 33. Then question number 34. A block of mass M is placed on a wedge of mass capital M, which is placed on a horizontal plane. The free body diagram of the system is shown in figure. Out of forces marked on the diagram, what could be considered as action and reaction? We can get action and reaction. Weight component of object in this direction is G. It is equal and frictional force is F. E is the reaction on the object. C is the weight component of perpendicular direction. No, D is the weight component. There is a problem with diagram. C should be start from this point. Then C is the reaction on this wedge. Then reaction on body and reaction on wedge should be action and reaction forces. E and C are action and reaction forces. And A and B. B should be force on wedge and A should be force on flow. Then B and A also action and reaction. Then we can get two pair of action and reactions, E and C, A and B, EC, AB. Answer is 4 for the question number 34, but there is a problem with given diagram. Forces are not marked with correct initial point. Then 35. A ball of 0.5 kilogram, which is initially at rest, is struck by a bat. The variation of force F on the ball with time is shown in the figure. The speed of ball when it leaves the bat is. Initially at rest, we know that change of momentum is area of ft graph. Area of ft graph half into x-axis 2 milliseconds, 2 into 10 to the power minus 3, base, perpendicular height 2. It also kilonewton, 10 to the power 3 Newton. This is the area of the graph. It should be equal to change of momentum, but initially there is no motion. It is at rest. Therefore, this one should be equal to mv product. Final velocity is v. We can cancel out 2 and 2, 10 to the power minus 3 and 10 to the power 3. 2 equals to mass of the ball 0.5 v. Then we can find the v value. 2 divided by 0.5 is 4 meters per second. Then answer is 4 for the question number 35. Then 36. A heavy roller of mass 500 kilogram moving on a horizontal surface at constant velocity 1 meters per second as shown in the vertical shown in figure is stopped in 0.5 seconds on hitting a smooth wall. The horizontal force exerted by roller on the wall is. We have to get force is rate of change of momentum, mv minus mu over time. We have to find force, mv product, mass 500 into velocity 1. No, there is no final velocity. Force on roller in this direction should be equal to change of momentum in this direction. mv0 minus mu mass 500 kilograms, velocity 1 divided by time is given as 0.5. 500 divided by 0.5 thousand Newton Minus means it is in opposite direction. Then answer is 4 for the question number 36. Then question number 37. A small object is initially at rest, point O, and due to an internal explosion, it breaks into 3 parts and move away at constant at a certain instant after the explosion. The location of 3 moving parts are shown by the points A, B and C in the figure. If the mass of the part which is at point A is 6 grams, what is the mass of object in grams before the explosion? Initially it is at point O. And there are 4 parts. A is like this. B is at rest. C is in this phase after the explosion, after a few seconds. Now, there is a vertical displacement for this part and this part, and horizontal displacement for this part and this part. We can consider horizontal displacement. We know that the velocity is directly proportional to this distance. It is displacement divided by time. Then momentum of C in this direction, mass MC into velocity is C small square in minus x direction. Then you can get velocity T should be equals to mass of A into 2 small square. Then we can get 3mc equals 2ma. But in the given figure, O is not in the correct position. Therefore, we can't use conservation of linear momentum in vertical direction. When considering vertical direction, these 2 objects are moving in upward, but there is no velocity for a part in downward direction. Therefore, we can't get correct answer for question number 37. It is a problem with the given question in the book. Then we can't get the correct answer. Then 38. A gymnastic player of mass 500 kilograms lands on the ground vertically with velocity of 6 meters per second and with his body straight. As his feet touches the ground, he bends his knees while keeping the rest of the body vertical and brings his body to complete stop in 0.2 seconds. The average value of force exerted by the player on the player by the ground is during the period of 0.2 seconds. You know that force is rate of change of momentum. mv0, final velocity is 0. Mass of player 50. Initial velocity 6, we have to divide by 0.2. It is a minus value. Minus means force exerted by player in upward direction. Velocity is in downward direction, initial velocity. Then we can simplify it. 5 into 6, 30. 300 divided by 0.2. 3000 divided by 2. 1500 Newton. Answer is P for the question number 38. Then 39. A uniform rectangular wooden strip of length L and mass M is placed on a table along x direction and parallel to one of its edge, so that a part of the strip is x extended out as shown in the figure. Distance from the center of gravity G of strip to the edge of table is x0. Now small block of mass m is placed at the left edge of strip and initial speed of v is given to it along the strip is x in x direction. If the coefficient of kinetic friction between strip and the block is mu, the minimum speed that can be due to the block to topple the strip is. I will draw the diagram. It is like this. The center of gravity of the strip is in this place. Distance is x0. Mass capital M, then weight capital Mg. Initially, this block is at the left end of the strip. It is simple length and given a velocity v. To topple the system, the center of gravity of the system should be this point after moving this simple length mass to this side. The strip is not moving, therefore it is center of gravity of it is x0 distance. I will find this x distance to topple. To topple the system, the resultant weight means capital M plus simple mg should be acting in this line. Therefore, we can get torque around this point of capital Mg into x0 should be equals to simple m into simple mg into x. Then we can cancel out g term and we can find the value of x, mx0 divided by simple m. Therefore, total distance should travel by the simple m. Total distance. This distance is L divided by 2. Length of the strip is capital L. It is given in the question. Length divided by 2 plus x0 plus x. L over 2 plus x0 plus x. Then we can use conservation of energy for the simple M block. It has a kinetic energy in first situation, half mv squared, should be equals to work done against the friction. Work done against the friction is frictional force into total distance travelled by the simple M. Half mv squared, we can write force mu r, mu into reaction on this object is equal to x. Reaction is mg. Distance is this value, L over 2 plus x naught plus x. We can cancel out m term. We have to find minimum speed, velocity. V is the question. We have to find V value. Then I will substitute x value as this one. Mu G L over 2 plus x naught plus x value is capital M x naught divided by simple M. Right. Now we can get this 2 to the right hand side and we have to get the square root to find the V value. Answer is 1 for the question number 39. Then 40. An object falling down vertically in air suddenly explodes into 4 pieces. Which of the following diagram shows the possible direction of motion of force immediately after explosion. When considering a falling object, there is a momentum in downward direction before the explosion. Therefore, after the explosion, there should be a downward velocity. We have to find which of the following diagrams shows the possible direction of motion of piece immediately after the explosion. When considering the explosion, in the first situation, in first answer there is a momentum in left hand direction, but there is no momentum in left hand direction before the explosion. Therefore, it could not be the answer. For the second one, there is a momentum in right hand direction. There is an arrow in right hand direction. It also incorrect. Third one, there is no velocity in downward direction. All velocities are in upward direction. It also incorrect. Fourth one, there is a velocity like this. There is no velocity to balance this one. Horizontal part. If there is a horizontal velocity after the collision to a piece, and another piece should move in opposite direction. Therefore, fourth one also incorrect. We can get fifth one is the correct answer. There are velocities in both directions when considering horizontal components, and when considering vertical components there is a downward velocity. Then answer should be 5 for the question number 40.